Here, question number 7 of grade 2018 Civil Engineering morning session is discussed. Question is, a solid circular beam with radius of 0.25 meter and length of 2 meter is subjected to a twisting moment of 20 kN about the z-axis at the free end, which is the only load acting as shown in the figure. The shear stress component, that is tau xy, at point M in cross section of the beam at a distance of 1 meter from fixed end is to be calculated. So here solid circular beam is given having a radius of 0.25 meter, length is given 2 meter. Twisting moment of 20 kN is also given. Now we have to calculate shear stress component tau xy, that is at point M in cross section of the beam. So beam is subjected to shearing stresses in planes YZ as well as ZX only. So only non-zero stresses are tau Z is equals to tau, and if theta is equal to 90 degree, then theta will be equals to y. So only non-zero stresses were tau theta z and tau z theta. Now if we just put 90 degree as theta, then we'll get theta equals to y. So we can calculate tau zy, which is equals to tau zx, and that is equals to maximum stress, which is equals to 16 multiplied by t divided by pi d cube. If we just insert this value of t, which is given, and we have converted in terms of Newton and mm. So d, we already have a radius, from there we can calculate diameter, and accordingly we'll get 0.815 ampere or 0.815 Newton per mm square. So this was regarding the stresses. But as per the theory of torsion, circular cross section should remain circular before and after torsion. Otherwise, distortion occurs in the shape of the cross section. So this is already a theory of torsion, where we are saying circular cross section is going to be remain as circular before as well as after the torsion. So in rest of the plane, shear stresses are coming out to be 0. Hence, if we just check the shear stress in the plane of xy and yx, that will coming out to be 0. So the final answer is 0, that is option number A. So here in this question, student has to recall what is the maximum stress and at what location or on which plane it is going to act. So accordingly, he can just simply answer this question within 30 seconds. So just question setter wants to know whether student can be able to mark the option properly related to shear stresses. So there is one more thing student has to keep it in mind, that this as per theory of torsion, circular cross section remains circular before and after torsion. If that is not the case, then distortion occurs in the shape of the whole cross section. So therefore, in the rest of the plane, shear stresses are coming out to be 0. And that's the final answer.